and tries the charm. My first one was way too long, so we're going to speed this up. Okay, so my name's Nicole. For those of you who didn't watch my video last week, I wanted to figure out how to bring it around to what I talked about last week, which was strokes. So this week, I decided that I was going to look at age and BMI because an increase in BMI is obviously strongly associated with cardiovascular disease, CVI, stroke, and several other health issues. So I wanted to see if the data that I had heard about in my past educational experiences was true, which is as we age, we see an increase in BMI. But I didn't want to look in the US because I feel like we live in a really obesogenic environment, and I wanted to look at a place that was a little bit less like that, I suppose is the simplest way to put it. So I was looking around, and one of the studies I found was done in Norway, which we'll scroll over to that real fast. And it was done over 11 years. It was a cohort study, and they were just following people around just to see how their BMI increased. And I didn't read thoroughly. I did read through and saw that they were 581 men and 588 women. And for my purpose, I wanted to look at women because I am a woman. So it's the data that obviously pertains to me the most. So I took this little graph that they had, and all it does is it tells, this is for 1990 and this is for 2001, and it's the averages, and then it has the standard deviation applied for each men and women. So I looked at this data here specifically, like I said, and this is the weight in kilograms, this is the BMI, and then this is their age. So what I did is I had to make up data because they didn't have a table that just laid it out all nice and pretty for me. And so I took about 5 people from each of these age groups. I made up the ages, and then I stuck them pretty close to at least within the standard deviation for the BMI that they had had. So this is what that data looks like. Like I said, there's 25 individuals, 5 from each of those groups, and then I took the BMI and I played with the standard deviations a little bit. So I think that played a role too, but it was interesting to look at, and I think with a bigger population it would have been even more interesting. So then I just wanted to look at the minimum, the maximum, and the mean. So all I did to do that was you click in the cell that you would like, and then there's this little function button, and it has this drop down menu here. So let's say I go right here, I click function, and I want to look at the minimum. All you have to do is search for minimum, and then okay, so it's going to do it for those, but you can grab the cells that you want the minimum for, go up here, and then click enter, and it will have your minimum. So that was the minimum for BMI, which is 23.8. So I went through and did that for each of these cells and each of the variables that I wanted to look at, which was minimum, maximum, and mean. So the minimum age was 21, the maximum was 77, and then the minimum BMI was 23.8, and the maximum BMI was 26.5. So that's not too bad. BMI is body mass index, by the way, so it's just a way of looking at your body mass in perspectives and comparing it to normative data. So the average, give or take, and you can go into a lot more detail than this, but for the purpose of this presentation, I'm just going to tell you that the healthy cutoff is usually around 25. So once you get above 25, you start to reach the overweight and then the obese categories respectively. So 26.5 is not that bad. So these Norwegians have something right going on in their life. I think we need to take a note from their book. Anyhow, I'm not sure what happened here. Oh, I know what I did. Okay, so these gave me crazy numbers, so I just went back in, and you can click these buttons up here to either increase or decrease the decimal places. I'm only interested in 2 at the most. Any more than that, my eyes start to cross. So then I wanted to look at how do these relate to each other, and do they have any sort of trend. So all I did was I selected the cells that I wanted to compare, and then I went to insert and chose the scatter plot. So I just found the image of a scatter and then clicked scatter. And this is what I got, which was great because it already had everything where I wanted it. It has age down here, it has BMI over here, And for the most part, I like this, but I wanted to change the scales a little bit. So because mine, my ages were not from 0, and I just think that that's a little bit too much. So I just went in here and then I did axis options and changed my minimum to 20. And I'm only going to bring it up to 80, which I believe it automatically, yeah, it goes ahead and automatically fixes that. So that was nice. And then if I was comparing Norway to other countries, ideally these age scales would all be the same on each of the graphs. The BMI scales would be the same on all the graphs. But as far as this table goes, because I'm just looking at one scatter plot for one set of data, I'm only concerned about pertaining to the data that I have. So this scale almost worked for me, but I want to make it a little bit simpler to read, and the way that I wanted to do that was by starting at 23. And you'll see in just a second how that changes things. It just makes it a little bit simpler, and you might, I don't know, some people might not see that big of a difference, but I didn't want it to start super far down. I didn't want these to be too close over here. 23 was just, it seemed like a good number for me. I don't like starting at 0.5s. Personal preference, I guess. So then all I did was I edited the chart title, which you just click into it, and I added the vertical and horizontal axis titles, which all you have to do is click one to add it and then click into it to change and edit the name. And I did that for both of these. I'm going to show you the actual graph that I created in a minute. But so right now this is looking pretty good. Now, one thing that I don't like that Excel does is it makes the font so small, and I don't know why it does that. So I go over to 12. I think at least a 12 is what you need when you're looking at data like this. Especially, I can't even imagine if this was like a lot more than numbers. It would have been terrible. Anyways, then I wanted to look at the lines. I wanted to look at the trend line. So I went ahead and went back to, gotta click into this again, the chart design, and I found trend line and then added a linear trend line. And you know, honestly, when I was looking at this, I didn't think that I would find one. And now that this is in here, I feel like, you know, it's not as bad as I thought it was going to be. It's obviously not as steep of a trend line as we would see in the United States, and I'll explain that. But for now, I'm going to go in here and just show you the basics of how I designed this. So I wanted a solid line. I messed with the color a little bit and ended up sticking back with blue, but you can change the color if you want. It kind of makes it stand out a little bit more too. And then I wanted to show the equation with it. So I went ahead and put display equation and then got rid of some of the decimal points. Like this 0.04 is not important. And now we're going to talk a little bit about what this means. So I'm going to go down to the other graph, and we're going to talk about the correlation that I found and a little bit about what all this means. So to find the correlation, I just did the same thing that I had done before. So you hit function correlation, and then you highlight the cells that you want to find the correlation between. So my correlation was positive 0.49, which isn't a strong correlation by any means. I would consider a 0.49 to be a rather weak correlation, but between 0 and 1, it's right in the middle. So it's about a mild correlation, a mild positive correlation. And when you look at this, you can kind of see that. So it's not, everything is not quite right on the line, and it's slightly sloped upward. Now, when we're looking at the equation too, all this means is that for every year, you would gain 0.02 points on your BMI after 23.9. So, and that's pertaining to this data. I think it'd be interesting to look at these equations in bigger populations and with the actual data that they used to write that article. And even in the US, I think that this would have been a lot more. I think that rather than it being 0.02 points for BMI, I think at a certain point it would reach an area where you would probably gain 0.05 points per year, because we're in a much more obesogenic environment. There's a lot more opportunities to gain weight here, and it's kind of become part of our culture. So that is all that this is talking about. So, and as we're looking at this, we see that the 0.409 positive correlation, or 0.49 positive correlation, it makes sense, right? With the data that we got, people didn't really gain a whole lot. I mean, the average was 25, which according to our normative data that we have, 25 is when we start being overweight. So I'd say that these Norwegians are doing something fantastic, because typically in women you see higher BMIs, and this is all data that was taken from that table for women. So overall, not a super strong correlation, but interesting data to look at. So I hope you guys enjoyed and maybe picked up a few things. If you have any questions, let me know. Or if anybody finds any data from the US that's like this, I think it'd be interesting to look at. Maybe sometime in the future. All right, thanks guys.